In this video, we are going to talk about the quadratic formula. Now, the quadratic formula is a way for us to find out what makes our standard form quadratic equation equal to 0. Now, there are other ways that we can find what makes it equal to 0. We can use the diamond method if you are familiar with that, or if you have watched some of my other videos on factoring quadratics. We can also use the completing the square method. But the quadratic formula is a method that works for everything. So if the diamond method doesn't work, or if completing the square just seems too complicated, the quadratic formula will get you an answer. It's not the nicest of approaches because it is a rather big formula, but it will always get you your solutions. And what do those solutions represent? Well, if we think about graphing the quadratic equations, there are 3 general types of shapes that we could have. We could have a parabola that goes below the x-axis and goes back up. We could have a parabola that just touches the x-axis and goes back up. Or we could have a parabola that never touches the x-axis. And what the quadratic formula does is it tells us where does it touch the x-axis and what those values are. So it'll give us 2 solutions for some, 1 solution for others, and then no real solutions for the ones that never touch the x-axis. And I should say that these could also be upside down, but we're not going to have to worry about that. If it's right side up or upside down, the quadratic formula will give us the solutions. So let's take a look at what this quadratic formula is and how we are going to use it. So here we are. Like I said, if your standard form is equal to 0, and only if it's equal to 0, then your x values that make it equal to 0 are the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Like I said, this is a very, well, I shouldn't say complicated, but it's a big formula. It's very similar to when we use our diamond method, though, because we need our a, our b, and our c. Once we have those 3 values, we plug it in, we work it out, we use our calculators if we have to, and then we call it a day. So, we are going to do 2 examples using the quadratic formula. Let's get started with our first example. We have x squared plus 3x minus 7. And while you might not see this, we're going to be told to solve, so we're going to say that it is equal to 0. But even if it's not equal to 0 for the purpose of this video, we are going to be solving it as if it was. So, formula's right up here. First, let's get our a, b, and c. A equals 1, b equals 3, c equals negative 7. Now, once we have those 3 values, we are going to put those 3 values in for their specific spots. B's for B's, A's for A's, C for C. Let's begin with the very first part. Negative b, or the opposite of b. B is 3, so the opposite is a negative 3. Plus or minus the square root of b squared, so now we're back to the original b, so 3 squared. You're going to want to put that in parentheses, whether it's positive or negative, just to be on the safe side, minus 4 times a, which is 1, times c, which is negative 7, all over 2 times a, so 2 times 1. And this, as I said, this is going to equal the x values that solve our equation. So, we now have a set up quadratic formula. we need to solve this. We need to simplify it down. And I always like to start with the part that's under the radical. This is called the discriminant, and we'll talk about that in a later video. But for now, we're going to work on this part. And when I work on this part, I like to show my work above the radical, and then I'll rewrite it in the end. So we have 3 squared, which is 9, minus 4 times 1 times negative 7. 4 times 1 is 4, times negative 7 is a negative 28. So that's what's going on under the radical. When we are subtracting a negative, it's the same thing as adding a positive. So we get 9 plus 28, which is 37. Okay, now that I have that part that's under the radical, I'm going to rewrite it. X equals negative 3 plus or minus the square root of 37 all over 2 times 1, which is just 2. And we're done. There's our solution. That is not a nice number. We don't want to evaluate the square root of 37 in our calculators. We're going to leave it just like this. And what this is telling us is that there are 2 solutions. Okay? We have one solution that is x equals negative 3 plus the square root of 37 all over 2. And we have a second solution that is x equals negative 3 minus the square root of 37 all over 2. But I'm perfectly fine with you leaving your answers like this. Just make sure you've got the plus or minus where it needs to go, and you didn't forget the square root. So there we go. We have just solved this. And we took what hopefully you'll agree was a very intimidating looking formula. We pieced it together, worked it out, and while we didn't get the nicest looking of answers, we didn't really have to do all that much math. We did more substituting than we did math. So that's nice. So let's try another example now. All right, here is example 2, x squared minus 8x plus 10. Once again, we're going to pretend that this is set equal to 0 so we can use the quadratic formula. And we'll put the quadratic formula back up. It is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's get going. What is our a, our b, and our c? Hopefully you say that a is 1, b is a negative 8, c is 10. Now that we know those 3 values, we can plug them in to the formula. So x equals the opposite of b. Now this time b regularly, or normal b, is negative 8. So the opposite of b is going to be plus 8, positive 8. So we'll just write 8. Plus or minus the square root of negative 8 in parentheses, squared, don't forget those parentheses, minus 4 times a, which is 1, times c, which is 10, all over 2 times a, which is 1. So 2 times 1. All right, we have successfully put together the quadratic formula again. So I'm going to move this down just a little bit so that I have the opportunity to write above it like I like to. Because first we want to take care of what's underneath the radical. We want to work out that discriminant. So negative 8 squared, if you don't know this off the top of your head, if you type it into your calculator, make sure it's exactly as you see it here. Parentheses around it, square outside the parentheses, otherwise you'll get the wrong number. So that is 64 minus 4 times 1 times 10, which is 40. So we get 24. I can rewrite this now as x equals 8 plus or minus the square root of 24 all over 2. And once again, I'm done. If this was a little bit more advanced of a math class, we could talk about how we could simplify the square root of 24, but we're not going to be worrying about that right now. So we have successfully solved this video, or this second example as well. There's one more thing I want you to know about, because some problems that you run into might work out a little bit differently. So I'm going to just move this up a little bit, and we're going to pretend that in this problem, okay, draw the little boundary, we're going to pretend in this problem that we ended up with x equals 8 plus or minus the square root of 25 over 2. Now the reason why I'm showing you this is because 25 is a perfect square. It's 5 times 5. 5 times 5 is 25. 24 is not a perfect square, so I don't have to worry about this with the actual answer. But 25 is a perfect square. So because of that, I can actually take the square root. And I would say that x equals 8 plus or minus 5 divided by 2. And now, because this was a square root, or a perfect square, and we could take the square root, we actually have to evaluate the plus or the minus. Otherwise, we didn't truly get our answer all the way as simple as it could be. Here, we've done everything we can with our knowledge. Here, we can do a little bit better. So we got x equals 8 plus 5 all over 2. Which is 13 over 2. And then we have x equals 8 minus 5 all over 2, which is 3 over 2. And those would be the solutions if we had the square root of 25. So that could happen, but that is not the answer we were looking for the original problem. I'm just showing you this special case. With that said, hopefully you have some more practice now with the quadratic formula. Find those A's, B's, and C's, plug them in, and work it out. Good luck.